Hello, everybody. Hello, everybody. We're going to go back to the normal live stream experiments that I sometimes do. Just going to switch things up a little today. I think I want to top off. Those fluids there. Hello there, Blue Crystal. We got some experiments for you today. Give me a second here. I'm going to top off the fluid in both of these flasks. Got some water stirring on some magnetic stir plates. Got a little bit of universal indicator to both flasks. See what happens. Yeah, welcome aboard, Blue Crystal. Okay, here we go. I'm going to add some universal indicator. How you doing there, Charlie? Universal indicator. Here we go, baby. Pop a little in there. See what happens. All right. I'll pull out some universal indicator into. Oh, there we go, into this dropper. Let's pop it in. I'm using my tap water today, and you can see that we're doing some universal indicator experiments there, Charlie. I've got some of my tap water in both of these flasks, and I can see that my tap water is essentially neutral. It's got some additives in it. Let's try this one over here. Pretty much the same. Turns a nice forest green color. We'll add a little bit of acid and base to both of these. So let me just show you this first. If you haven't seen these experiments, this is a common experiment that I do on my live stream. All right. Notice that the color of the universal indicator has changed to a green color. So that's going to tell us that both waters are neutral. Let me add a little bit of acid to the flask on the right. So the acid I'm adding over here is hydrochloric acid. It's the same acid that's found in your stomach. We're going to go 2 drops. 1, 2. And you see that the color shifts to like a red or an orange at first. And then as it homogenizes, it goes to yellow. So you can see, that sounds cool, Giga Bean. So upon adding acid, the pH dropped, right? We went from pH 7 down to pH 6. We're going to do the same over here on the left. I'm going to add some sodium hydroxide base over here on the left. So there in goes the base. Some people call it alkali. Here in the United States, we use base and alkali synonymously. Oh, glad to hear you're missing chemistry there, Charlie. So look at that. On drop of base, it's pretty concentrated base, the pH drastically increased from like 7 to 10. We got like a violet solution over here. So yeah, you see that when you add acid, the pH goes down. I'm going to add a little more acid over here on the left. 3 more drops. See if we can get an orange or red color. Sure enough, and then we're going to add base. When I add base, the pH increases. And what's nice is that it, the color takes a while to homogenize. Let's just add a little bit of base over here just for the heck of it. Boy, you can see that blue color develop in. And then what's neat is like those different colors persist for a while, which I think is quite beautiful. It takes chemical reactions time to occur. And so the pH changes that you see, those are going to take a little time to occur. And as the flasks homogenize, it'll take a bit of time for the flask to gain a homogeneous color. Let's go ahead and let's see some acid over here on the left. So I'm going to add drops of acid. There's 1 drop, there's 2 drops. If you're careful, you might notice a red thread in the middle. And wow, when that hits the bottom, you can see that color change. And that color change is indicating that indeed the pH is dropping. Keep adding a bit more. Let's go a bit more acid over here on the right. A bit more acid over here on the left. Kind of cool. What I want to try to do is get the rainbow effect. Sometimes you can get all the different pHs in the flask at the same time, which is really kind of cool. We're going to try that right now. So I'm going to add 1 more drop over. Can I make a video about chloroform and how you have to mix bleach and acetone? Interesting. Yeah, I'm probably not going to make chloroform. Here we go. Let's put a drop of 2 drops of base over here on the right. We'll do a single drop of base on the left. Hey, we got it. We got a flash of the rainbow over there. It's so cool, man. That's so cool when that happens. Love the rainbow. Let's get a little more lighting. Maybe we'll see it a little better this time around. Yep. Now we're talking. Got to get that lighting just right, and then we can really see the colors pop all the way up and down the flask. Taste the rainbow, baby. You know a detail machine. Somebody's following the details. Here we go. There we go. All right, let's try another drop of base over here on the left. Let's see if we can get that rainbow going on. Yeah, we got red and yellow colors. There's a couple drops of base over there on the left. There it is! A transient rainbow. Let's put a little acid in there. We'll do the same over here on the right. A couple drops of acid. Oh, it's gorgeous. Gorgeous color. Hello there, Brittany. All right, come on. Let's do the rainbow now. 2 drops. 1, 2, 2 drops. 1, 2. Let's see what we get. Let's see what we get. Oh, I love it. You can taste everything, just not everything twice. That's funny. Hello there, John Wayne. Hello there, Duet 21. Funny detail. Yeah, it is pretty colorful. Hello there, Rahul. What is this, Fishy Edits? What it is I have 2 flasks. Both the flasks contain water and some universal indicator. Universal indicator is also known as rainbow indicator, and it displays different colors at different pH values. And pH just tells you how acidic or basic something is. So right now, both flasks look quite red. That's because I've been adding a lot of acid to both flasks. The acid that I'm adding is the same acid that's found in your stomach. It's just that the stuff in this bottle is like 100 times to 1,000 times more concentrated. So right now we can see, the pH is like 3 or lower. And then if I start adding base, the specific base I'm going to add is sodium hydroxide, a solution of sodium hydroxide base. Let's go ahead. I'm going to add maybe 2 drops to the right. You see that violet color grow in, indicating a pH of 10. But the acid and base, they react with each other. They neutralize each other. And you end up getting a whole variety of colors because, the acid and the base, they neutralize each other. They pull each other closer to 7. And, in the chaotic mixture that is the stirred solution, there's a whole bunch of different pH values that can exist at the same time. So that's what's going on. Try to do it again. A couple over here, see what kind of colors we get. Yeah, we're getting the rainbow pretty good today, folks. The setup I've got is working. Come on, man, look at that. That was beautiful. That was beautiful. It's kind of fun to do this, too. It's kind of fun to have like a dynamic rainbow. So this one over here, I'm going to put a bunch of acid, which is going to make the pH drop. So I've added a bunch of hydrochloric acid. We see that pH dropping around, pH 3, so it should turn red. Over here on the left, I'm going to do the same thing. We're going to do a bunch of acid over here on the left. How to clean your pool deck. Alex, it depends what's on your pool deck. The green is beautiful. It's tough to catch, though. Okay, now this one over here, we're going to turn off. I'm going to turn off the stir bar. Hello there, Luca. Luca loves some physics. I'm loving me some physics, too, there, Luca. So this flask, we're going to call this one our static flask because it's set. Oh, good question, Blue Crystal. We'll do that in a second. This flask over here, we're going to maintain the spin, so we're going to call this the dynamic flask. Let me go ahead and add like 2 drops over here to the dynamic flask, and we'll add 2 drops over here to the static flask. See that rainbow grow in right away over here on the dynamic flask. And it's not quite homogenized yet. Auspicious. They turn back to red because I add hydrochloric acid. It's the same acid that's found in your stomach. So anytime you see a shift to red, that tells you that I've added some acid. It does not, Alex. It's beautiful how some misbehaving electrons do this rainbow show. Love it there, Glitched. Nice there, Giga Bean. Here, we'll go ahead and add a bunch of acid over here. We got a little green color, but I'm going to add 2 drops of acid, hydrochloric acid, same acid that's found in your stomach, except this stuff that I add is like 100 times more concentrated. It's not quite acidic enough, so I'm going to keep adding a couple drops of acid, try to get that back to a red color. Happy birthday there, V4. Happy birthday. Hello there, King Roman. Interesting. So Charlie is saying that in German, hydrochloric acid is called salt acid. Here in the States, we refer to it as stomach acid. That's interesting. I like it too there, Detail. Come on now, the slow and steady static reaction is kind of fun. You know, this takes longer because this, of course, the stirring's not happening in there. Noto Bird, I'd go to the doctor if that's true. Hello there, Linus. Okay, let's add a couple drops of base over here on the right. See if we can't get the rainbow. I'm going to add another drop of base over here on the left on our static rainbow. I guess it's not really a rainbow. Here we go. 2 drops of base. Let's see what we get. Hello there, Devin. Yeah, that all depends on your friend's name there, King. Linus, what we are doing is we are adding either acid or base to water that contains universal indicator. Universal indicator is also known as rainbow indicator. It displays these colors at different pH values. Sure, we can say happy birthday, Kevin. All right, here we go. A couple drops there. A couple drops here. Oh, we caught the rainbow, baby. We caught the rainbow on the right. Come on now, that's some cool stuff. Let's add a little bit of acid over here to our static flask. Boy, that rainbow's persistent pretty long. It's quite beautiful. Let me get a little bit of acid action over there on the left. So, Neela, what we are doing is I have added universal indicator to both of these flasks. Universal indicator is also known as rainbow indicator. We call it that because it displays the colors of the rainbow. But the particular color that you're going to see depends on the pH of the water. So you can see here, you know, this flask over here is pH 3 or 4, somewhere in that neighborhood. I'll add a little bit more acid to get it down low. It's like 3 or lower. So this indicator will shift to a red color when I add acid. Watch what happens when I start adding base. The pH should go up because the base will neutralize the acid. There's 1 drop. So you see violet grow in because the base indeed has a pH of 10. And you'll notice that the base neutralized some of the acid. It brought it from like a pH 3 to maybe a pH of 4 or 5. I'll add another drop of base. There's another one. So Auspicious Jelly is telling us, hello there, Aniela Puga. Sorry, I'm not saying your name right. The left side looks spectacular according to Auspicious Jelly. Similar to nebula pattern exploding stars. And it's also intriguing that fluid dynamics is found in both micro and macro scales of the universe. Beautiful, beautiful. That's a top tier comment there, Auspicious. I'm agreeing. I am agreeing. So a bunch of base would make it green. Let's find out, Noda Bird. Here we go. I'm going to add a bit more base. 1 more drop. And there you go. There's your green. And in fact, I may have added enough base. No, I think that's green, like a greenish blue. If I continue to add base now, we should be able to pull the pH to like 8, 9, or 10. So now, yeah, the pH is like a 9. And oh, there it goes. That looks violet. So now we got a pH of 10. So why is the first glass a mix of different colors? Since it's not mixed well. That's exactly why. Okay, there. Nilavar, V, the reason why is this is not being mixed. And so it, the drops, here I'll add a drop of acid. You can watch here. I'm going to add a drop of acid up here at the top. Right there at the top. And you can see as it, well, it's easier to see the base. Let me add the base. I'm going to add the drop of base. Watch, it'll go purple. Boom, look at that purple flow going on. As the base sinks, you can see that it's changing the universal indicator to a purple color, indicating pH 10. Now, that purple fluid, so to speak, it's going to be reacting with the surrounding mixture. And it takes a while for it to homogenize if I'm not stirring the mixture. And so the acid and the base will react, and as they react, they pull each other closer to neutral. And it just depends. If there's more acid around, it may only go to like pH 4, 5, or 6. If there's more base around, it might just go to pH 8 or 9. If they're perfectly balanced, it goes to pH 7 green. So that's what's going on. Notabird, it's called a magnetic stir bar. Thank you there, Charlie. I'm adding acid to the flask on the right now. That's what's causing those color shades. Look at that gorgeous flow over there on the left. If I provide heat from my hand, you're welcome, Neela. There we go. Heat from my hand. Not a whole lot. Hello there, Daniel. Not a pie. It has a slight stench. That's because the universal indicator is dissolved in ethanol. That's the same type of alcohol that people drink. All right, here we go. You're scaring me, Danielle. I hope you're not telling me the truth. I hope your company's name is not Tommy Technetium. Yeah, that's the name of this channel, Tommy Technetium. I do a live about once a week on the weekends. Indeed. Yeah, let me know if the sound's bad or if Matthew is just spamming the comments, because if he's spamming, we're going to go ahead and block him, all right? Just let me know if the audio's fine. What's it taste like? It tastes like a really bad afternoon because one of the indicator dyes is a laxative. Current shirt. Yeah, we'll pop that on. Thank you there, Humphrey. I appreciate that. So, Taylor, you're saying the audio is good. Stop spamming the comments, Matthew, and you are welcome aboard, buddy. Yes, it is, Brandon. It's actually a mixture of 4 different indicators. Okay, thanks. It's a mixture of 4 different indicators. So the question is universal indicator organic? It happens to be a mixture of 4 different organic materials. The first is thymol blue, which shows these colors at different pH values. So this is kind of the backbone of universal indicator. And then they add in 3 other indicators to give your overall color of the universal indicator. So methyl red is going to show like a red or a yellow. Bromothymol blue, that's get your yellow, green, or blue. And then phenolphthalein, that's colorless or pink. The pink is added, it's like a deep red, so that you can get the blue and the pink to give you the violet color at pH 10. I love it, Charlie. Thanks. Hello there, Taida. Welcome aboard. Anyway, sure, Nam. I can keep the universal indicator chart on the screen. Give me a second here. We'll keep it up there. I'm not going to keep the complex one up there. Let's just leave. Let's leave this one up, okay? It's a little big here. Let me fold it in half so we can see it a little better. There we go, like that. Kind of like that. There you go. Hello there, Kurt. All right, what are we going to do? I'm going to move this over here so we can see the action over here in the flask on the left. I'm going to go ahead and add some acid over here. So long, Charlie. Great to have you on board. I'm adding acid to the flask on the left. I should cause a pH drop, down to pH 3 or so. You can see it right there. I'm a Buster. I'm the happiest mad scientist you'll ever meet. Okay. All right, now we've got the red, so that's a pH 3 or lower. And now what I'm going to do is I'm going to add some sodium hydroxide base. Hello there, Tuddy. How you doing? We're going to add some base, see what happens. Here we go, 2 drops. Boom, boom. See if we get the rainbow. NPES, indeed, pH 11 is alkaline, but anything actually above pH 7 is alkaline. So in the States here, we'll also call it base or basic. So like an alkali is a base, something that's alkaline is basic. Hello there, Mecca. We got a nice aqua color. That's pH 8. That's a rare color. I tend not to see that one. That one's hard to get. Blue Crystal says, fun fact, pH 7 is the pH of the human body. In places, Blue Crystal, but like in your stomach, the pH is like 1.5. And I think in your intestines, once the food gets to your intestines, I think it's basic there. I think it's like pH 8 or so. What a great question, Taylor. Ah, I see, Soleil. That's interesting. Anyone know the pH of the brain? Taylor, I'm loving the question, man. Loving the question. Someone Google that and drop it in the comments, all right? We'll have a couple people pop it in there just so we're getting, a couple different checks. What is the pH of the brain? I don't know. I want to know. I want someone to be Googling it for me. Or maybe ask an AI chat. I'm guessing it's acidic, Soleil, but someone grok it. Here we go. Namely, the brain maintains a relatively stable pH with intracellular pH around 7.2 and interstitial extracellular pH around 7.3. So looks like you're right. Yep. Interesting. So slightly basic. Thank you, everybody. Come on now. We're getting a lot of consistent answers. I'd love to see that. So, Taylor, why do you think that makes sense that it's slightly basic? I don't know much brain chemistry, which is why I'm asking the question. What's the role of drinking alkaline water in your body? Niraj, what that does is it makes a lot of money for people who scam. It's just a marketing scheme. That's all it is. Because as soon as the alkaline water hits your stomach, it's neutralized. If you'd like to see Niraj, what you want to do is you want to go ahead and watch the latest video I dropped this Saturday. Just go ahead. It shows me doing a lecture. So the last video, I gave a lecture at a conference I was at with a bunch of chemists. And what we did is we took some alkaline water, and then I added the amount of protons that are in your stomach. In other words, I added the amount of I added the amount of acid that's commonly found in your stomach to a full bottle of alkaline water. So check it out and let me know what you think. It's just a marketing scheme. People get stuck on these ideas sometimes and they have a hard time getting off of them. All right, we're gonna go ahead and make this one. We're gonna move it on, man. We're gonna get this one going. Here we go. Thank you there, Jimmy J. Here we go. We're gonna turn it on, see what happens. Thank you there, Sib. All right, let's see what happens. I got the one on the left stirring. And where's the pH gonna land? It looks like slightly acidic. It looks like we ended up at pH 6. Thanks, there, Matthew. Appreciate it. And I did see some further confirmation that indeed the audio is having trouble. I appreciate you letting me know, Matthew. Thanks. Sorry, I jumped the gun. Nam Lee asks, have you ever thought about using a buffer? Well, let's do that, shall we? Let's do that, Nam Lee. We're going to add a buffer, okay? So Nam Lee wants us to use a buffer in this experiment, and that's exactly what we're going to do. Give me a second, Nam Lee. Okay. We've got our first experiment suggested from the chat. Thank you there, Jimmy J. Appreciate the subscription. That's not going to happen. I'm not going to do any experiments in my basement that explode. I'm just trying to add just a little bit of acid to both of these. I'm trying to get the pH to 6, okay, on both of these. So bear with me. I'm adding acid to both. You'll notice that the pH is dropping. Both flasks should end up at a yellow color. Jason, what's going on is in both flasks, there is some universal indicator that has been added. Universal indicator, yes, Sam, it is a reversible it's reversible. Universal indicator changes color depending upon pH, all right? The acid nearage that I added was hydrochloric acid. So Gigabean, I got an iPhone, and it's probably just my internet connection is what I'm guessing. So here we go. We are at pH 6. Now what I'm going to do is Namli said, hey, what happens if you buffer this? So what I'm going to do is I'm going to add an Alka-Seltzer tablet to this. And that's going to form a citrate buffer in the flask on the left. Now, at first, it's going to look red because there's some aspirin that quickly dissolves, and aspirin is an acid. However, as the citric acid in the tablet reacts with the sodium bicarbonate, you'll see a bunch of bubbles. That's because there's a lot of carbon dioxide that's being produced. Here, you can see it up here at the top. You see all those bubbles? That's a bunch of CO2 that's being produced. And the ultimate end of the reaction is you get a buffered solution on the left around pH 6. It's got like hydrogen citrate and dihydrogen citrate. Good to hear it, Taylor. Thank you. Why the paper on the stir motor, Michael? It makes the colors look better. That's why it's just aesthetic. That's it. Okay, so now over here, I'm going to put this little thing over here so we know this is the one that has the Alka-Seltzer tablet added to it. So this one has been buffered. You can see over here, if you look, you can see. Let's do this. This is kind of fun. You can see a bunch of bubbles there. Sodium hydroxide reacts with carbon dioxide. So all those bubbles are carbon dioxide. What I'm going to do is I'm going to now add a bunch of sodium hydroxide here and watch those bubbles disappear. Come on, react them away. Get rid of that sodium hydroxide, baby. Or, excuse me, the carbon dioxide bubbles. Get them in there. I've gotten rid of some of them, but not all of them. Boy, and that took a lot. Notice how I added like a full squirt of sodium hydroxide to this, and we changed from like a pH 6 to a pH 7, so it did not change much. Hello there, Tutty. All right. Now I'm going to add just a single drop to the unbuffered solution over here on the right. Here we go, just one drop. Boom. And that's the difference between a buffered solution and an unbuffered solution. Here, let me add one more drop. So I added 2 drops over here on the left. Excuse me, on the right. So I added like a full squirt over here on the left, and it went from pH 6 to pH 7. I added 2 drops over here on the right, and it went from pH 6 to pH 10. So a buffered solution, it resists changes in pH. Thanks there, Jimmy J. Good to have you along. Hello there, Tutty. I'm going to try to add some acid over here. Let's add like 2 drops, 3 drops, 4 drops. There's 4 drops of acid over there on the right. It's a good question there, Taylor. I don't believe iodine changes the pH of water because iodine is not acidic or basic. What's pH? Jason Bourne, it is a mathematical description of the concentration of acid. I'm lying to you a little bit just to give you the idea, but it's a mathematical description of the concentration of acid in a solution. Gigabean, I apologize. I think it's 14, but I don't know. Do a time lapse for chlorine dissipation. Oscar, tell me a little more because I'm not sure I completely understand your question. All right, so I'm going to go ahead and add acid to the buffered solution over here. I'm going to add like 1, 2, 3, 4, 5 drops. Thank you there, Lana. Let's add 5 more. 1, 2, 3, 4, 5 drops. Thank you there, Cub. Let's add 5 more. 1, 2, 3, 4, 5. And we'll add 5 more. 1, 2, 3, 4, 5. That buffered solution, it's really difficult to get this buffered solution. The acid, Martin, is hydrochloric acid, 20% by weight. Ooh, Nom, that sounds rough. So, someone just joined. What are the solutions? Meow. They are solutions. Both of these solutions contain universal indicator. Universal indicator is also known as rainbow indicator, and it displays these different colors at different pH values. Yes, there is a pH 0 blue crystal. So we can see over here the flask on the right is at like pH 3 or below. Red is 3 or below. Over here on the left, we're like a pH 6 or 7. It's like a greenish yellow, so we're like in between 6 and 7. I'm going to go ahead and add some base to the flask on the right. That should increase the pH, and then we're going to change from a pH 3 to a higher pH. It's a good question, Niraj. Unfortunately, I do not have any, I don't have any vinegar with me, so I can't do that experiment. I apologize. I'm trying to get both of them to the same yellow color. Again, Gigabean, I apologize. I think it's iPhone 14, but I really don't know. I'd have to stop the live and look it up, and I'm not prepared to do that, so I apologize. Savannah, can I do an acids and bases titration? Kind of, Imam. I guess so. We can do that. Here, let's do it. That's a great question, World Raves. Somebody look up the pKa of lysergic acid. Taylor, we mostly ingest acidic items. So we tend to ingest food that's slightly acidic. I believe like Sprite, you know, kind of the low end of things that we ingest tends to be like pH 2. Like vinegar is like a pH 2. Sib, it tastes like a really bad afternoon because it's made of 4 indicators. These are the 4 indicators. This one, this one, this one, and this one. And this one is a laxative. So that's what it would taste like. Thanks, Sarah Gigabean. The cubics, the 2 fluids I'm using are universal indicator and water. This happens to be buffered. I added an Alka-Seltzer tablet to it. I am, Rahul. So here, watch. They're both kind of green in color. I'm going to add yellow in color. I'm going to add base to this one over here. This is the unbuffered solution. I added a single drop of base, and our pH went from 6. Let's add another drop. One more drop. So 2 drops of base. The pH went from 6 to... RJ, that's a base. So we went with 2 drops in the unbuffered solution. We went from pH 6 to pH 10. Indeed, I am a scientist, Rahul. I teach chemistry at a university. Over here on the left, we're going to do 2 drops. Remember, this is the buffered solution on the left. 1, 2. And in the buffered solution, the pH relatively remains unchanged. Interesting, Gigabean. Anamika, what we are doing here, what we're doing here is I am adding either acid or base to flasks that contain universal indicator. So over here on the right, we can see this flask is violet. The contents of the flask are violet. It tells us it's pH 10, which is very basic. Over here on the left, this flask is like a green or a yellow. So that tells me the pH over here is 6 or 7. So Taylor, then the pH of lysergic acid, the people who asked the question, what's the pH of a particular substance? If you go back, if you dissolve some of that in water, the pH would be roughly like 2 or 3. Pretty good acid. How's the buffer solution work? Imam, what a buffer is, it's a mixture of an acid and a base that don't react with each other. So when you add them, they don't react with each other, but they're present so that the base can react with any added acid that you add, which I'm doing here, and neutralize it. And the base that's already present in here will react with any acid that you add and neutralize it. Probably Oshk, but these reactions go pretty quick regardless of temperature. Anyuj, this is not grape juice. World Raves, I apologize. I don't understand what you're referring to. Alkaloids, RJ, those tend to be in the higher pH category. You can hear it in the name, alkaloid, alkali. Why can't gold be dissolved by acid, particularly nitric acid? Gold's very hard to oxidize. You know, nitric acid is an oxidizing acid, but it takes a lot of oxidizing power to oxidize gold. So some metals are just thermodynamically stable, and gold is one of those particular metals. Platinum is another. So even though nitric acid is really good at oxidizing metals, gold is just too stable. Yes, it can, Lana. Silver can be, you use nitric acid, you're going to dissolve some silver. If you guys want to see a video of mine where I dissolved a coin in some acid, you can go over to my YouTube shorts. Go to my popular ones. You're going to see one. Well, it's not really a coin. It's a token. But you can go to my YouTube channel, look at my popular shorts. I think I've got a video on there. A couple videos where I dissolve some coins in acid. Usually copper and iron. You're welcome, Lana. All right, let's do this. Let's get this acidic. I want to see if I can get the rainbow going. So, Tony, what I'm doing is I am adding either acid or base to water that contains universal indicator. Universal indicator is also known as rainbow indicator. It displays these colors at different pH values. So you can see this flask over here on the right. It's got a red color telling us it's pH 3. Over here on the left, it's got like a yellow-green color telling us that's like pH 6 or 7. If I go ahead and add some base, I'm going to add some base over here to the flask on the right, just one drop. That pH should go up because the base neutralizes the acid and brings it to closer to 7, which is neutral. So you can see it was red, and now it's like an orange-yellow color, so we moved it from pH 3 to pH 4 or 5 just by adding a little bit of base. Let's add a little bit more base over here on the right, see what happens. So long, Blue Crystal. Rainbow indicator, Peter, is a mixture of chemicals right here. Thymol blue, methyl red, bromothymol blue, and phenolphthalein. You add them all together, you get universal indicator. So what's making it spin? Let me turn off the spinners. What's making it spin is in each flask, you see down there at the bottom, there's a little stir bar, okay? And that stir bar is magnetic. Now this is a magnetic stir plate. It's like it's like a fan, and the fan blades are magnetic. So when I sit this on here, you can see that the magnet in the flask is attracted, to the magnet in the magnetic stir plate, which you can think of as a magnetic fan. And when I turn on the magnetic fan, the stir bar stirs, and that causes the fluid to stir as well. That's where you get the, there it is. That's where you get the tornado, baby. Come on, there it goes. There it goes. Thanks, sir. Guth. All right, this one's boring. This one's the what do I want to say? This one's the buffered one. Nothing's going on in the buffered one. It just resists changes in pH. Let's do this experiment. This one's fun. Let me make sure I got a straw. You guys are going to like this. I hope it doesn't take me too long. Let's see. I got to get a straw for this experiment. Oh, I better have a straw. I do. Awesome. All right, we'll set this one up. We'll put this on here. We'll put this flask right here. We're gonna do the straw experiment. Here's my straw. I'm gonna pour in some water. Let's see. What kind of water do I have? I don't have any alkaline water, which sucks. Oh yeah, I do. This will be fun. This will be fun, man. Okay, so here I have some essential water. This gives you a little idea of some experiments I did in that lecture I gave recently. Thanks, Sir Tony A. Okay, here we go. So I've got some essential water, which, you know, they say this stuff is like ionized hydration. What the heck are they even talking about? And then it's pH 9.5 or higher. That is true. That is true, okay? So here, well, I'll show it to you. So I'm going to take this essential water, and we are going to add it to this flask. And they claim that it's, you know, what? pH 9.5. So if it's pH 9.5, what color would we expect to see if I had the universal indicator? Well, it's going to be like a blue or a violet, right? Well, let's test that. Here, I'll stick this over here so we can see it. All right, so they say it's pH 9.5. So let's add our universal indicator. Here we go. We'll make sure I get one that's... Okay, here we go. Let's add this. So you can see the universal indicator, when I pull it out, it's green, it's neutral. And then we're going to add it to the alkaline water. And sure enough, it turns like a, you know, a blue or a violet color, showing the positive test. Indeed, they are not lying when they say that this has a high pH. But what they do say is it alkalizes your body. Well, let me just show you what a load of shit that is. Sorry, well, I guess I shouldn't say that. I don't get load of crap that is. Sorry. I don't know if you're allowed to swear on YouTube. I just did. Anyway, what I'm going to do is I'm going to exhale into this, okay? And as I exhale into this, you have to recognize that as I exhale, 4% of what I exhale is carbon dioxide. And carbon dioxide is an acid. So let's see how long it takes for me to blow into... This isn't even my stomach acid, folks. I'll do that next. I'll add the amount of protons, the amount of acid that's in the stomach to this stuff. But just watch how long me just breathing, me undergoing regular biological processes is going to produce enough acid to neutralize this essential water. Are you ready? Here, let's time it. Somebody put the timer on. Are you ready? On your mark. Can you see it? Yeah, we can see that. On your mark, get set, go. Neutral. And it's still going a little more acidic. So, you know, these folks, come on, man. These folks are going to tell you that this stuff is going to alkalize your body, and that's going to have some kind of health benefit to it. But come on, man. How long did the biochemical processes happen in my body neutralize this? Like it took, what, less than 10 seconds? Now, granted, I like the taste of this stuff. People tend to like the taste of water that's slightly basic. Just a little bit. And why is that? Because bases are like soapy. So they give a smooth, slippery feeling to the water. Really purified water has kind of a sharp taste. It's not as smooth or slippery. So you want to buy this stuff because it tastes good, by all means, go for it. I mean, I do because I think it tastes delicious. I do not like purified water. I don't like the taste of it. But, you know, don't buy into the snake oil stuff. All right, let's do this too, okay? Here's that bottle of water right there. So this is the essential water. I'm going to go ahead and add some universal indicator to it so we know it's indeed the essential water. All right. I'm sorry. There's something wrong with my phone, I think. Okay, here we go. Let's add a little bit. There we go. We can see, indeed, that it is a high pH as advertised. Now what I'm going to do is I'm going to add 1/3 of the amount of acid that's normally found in your stomach. Okay? Here we go. 2 drops is 1/3 of the amount of acid that's usually found in your stomach. And it goes 1, 2. So when this stuff hits your stomach, that's what happens to it. Oh, wait. The stuff that's supposed to alkalize my body is now at like pH 3 as soon as it hits my stomach. Because there's just a bunch of acid in your stomach. It's going to like... Anyway, don't get me... You guys got me started. I'll get off my soapbox here. Methylene blue. We don't want to get started on methylene blue, man. Come on, man. Okay. All right. Let's focus on this. Yeah, you do. Indeed, you pay big money for the names on the bottles. Yes, Sib. Red cabbage contains a class of compounds called anthocyanins, and anthocyanins, they're acid base indicators. You know, Brandon, I do hear a lot of people say that water does help with heartburn. I don't know. I don't know of any studies that have actually looked into this, like, placebo controlled double blind studies, which is that's what we do when we're testing the efficacy of medical claims. But yeah, I've heard people say it helps with heartburn. I have no idea. If I could have somebody show me a placebo controlled double blind study on that says it works, and yeah, then I'd believe it, and then I'd want to look into the chemistry behind it. I like some good old tap water too, there, Lord. Sure, Niraj, acid certainly can get neutralized by base, but you need to include enough base to neutralize the acid. And clearly, this doesn't have enough of it. Not even close. Thanks, sir, Dominic. Oh, RJ, I'm believing that. Milk is, you know what I like for heartburn is a Tums tablet, calcium carbonate. Makes me burp a little bit, but that's just from the reaction between the carbonate ion and the calcium carbonate and my stomach acid. That's not Abigail. Indeed, acid plus base is salt plus water. But if you have excess acid, then you have excess acid plus salt plus water, Niraj. You have to add enough base to neutralize the acid. And the alkaline water doesn't have nearly enough to do that. We've done several experiments that demonstrate this. So what is going on in this flask? I have some universal indicator added. And then to that universal indicator, I either add acid or base, and that just changes the color because the color of the universal indicator depends on the pH of the solution. So that's what's happening here. Just doing some acid-base experiments, baby. But I tell you what, I am getting near to the end of... oh, Red, you're doing fine. You hang out here long enough, this will be old hat. It's like anything else. I couldn't weld Scotch tape to a piece of paper. So you know what I mean? We all got our thing that we know how to do. That would be cool, United. All right, I tell you what, I've pretty much had enough. I'm going to flip the camera around. Here's your fair warning. If you don't want to see an old man doing chemistry, well, I won't be doing chemistry experiments, but if you don't want to see an old man in his basement, then now's your time to get out of here. I do flip the camera around and talk to folks here at the end. That's right, Lingo. That's exactly what I'm doing. But I'm also ending the live here soon. I'm just going to talk to folks for a bit, and then we're going to call it a day, okay? Had a great time with you all today. Let's get this camera flipped around. My wife just got home from work, and I want to talk with her. Penny test. Maybe next time there, Lumity. Thanks there, Lingo. Thanks for hanging out. Those of you who are taking off. So, Imam, it is what we call a Lewis acid. So if you're familiar with chemistry, it's a Lewis acid. Basically, carbon dioxide reacts with water, and when it does so, it makes the bicarbonate ion and releases a proton, an H plus ion. I'm assuming you know a level of chemistry. If I've said some things that have confused you, you're going to have to ask me some more questions. Sib, I usually do this on Saturday or Sunday afternoon. RJ, if you want to see the piranha solution, excuse me, check out my channel. I've got a video where I put a scrub daddy in piranha solution. It's a lot of fun. You got it, United Kingdom. Unfortunately, that is going on. Let's flip this baby around. Let's say hello to everybody. What's happening, folks? Turn that off. What's happening, folks? Thanks for joining in. Good to see everybody this afternoon. I had a good time. We had some fun. This is like the acid-base experiments that I do, that's kind of like the standard experiments I do. But, I do some other ones as well. I've done some glow stick experiments. Dissertation project. Abigail, have you done a dissertation? If so, drop the title in the chat. I'd like to see it. Like to see it, Abigail. No, Diva, I'm not. I am not. Thanks there, Ash. I appreciate that. Yeah, consider giving a subscription, Tommy Technetium, if you like this kind of thing. Abby, please, seriously, drop the title of your dissertation in the chat. 3rd year, nice. Abby, so I can tell you the gist of my dissertation in 2 words. You ready for it? This is a real challenge. No rebirth. So here we go, Abby. Here's the gist of my dissertation in 2 words. Nobody cares. Nobody cares, man. There are like, 100 people maybe around the world that were, interested in this deep, I don't want to say deep, but yeah, this deep chemical topic that I got into, which was, was interesting and all that. But ultimately, man, I mean, nobody's thinking cares. Thanks there, Mr. Astor. Appreciate it. Diva, I do enjoy Coca-Cola. All the sugar. Man, the sugar. It's one in Michigan. So, Sib, my dissertation project, what I did is I looked at an enzyme, a protein, that speeds up a chemical reaction. It's one that does it in plants, and it happens to do it in photosynthesis. So this speeds up, actually, photosynthesis is a whole bunch of steps to it. And I looked at the very first step of photosynthesis, which interestingly, in that very first chemical step, water goes into the plant, it hits the enzyme that I studied, and that water gets split into oxygen. So that first step of photosynthesis is like really important to our lives here on Earth. We need oxygen. So peanut butter there, Lumity. So yeah, I looked at that, and I can go deeper if you want, but that's the really basic idea of what I studied. It goes a lot deeper. Kanika, I am a chemistry professor, and I do a lot of like science communication, science education. What I'd call that my expertise. I try to invent new chemistry demonstrations. I actually have a book coming out. I don't know if I'm going to share that on my YouTube channel, but yeah, I have a book coming out. It should be coming out sometime this month on chemistry demonstrations. So Abigail says that they love synthetic chemistry, love making new things. Synthetic and structural characterization of trinuclear copper pyrazolates and photoreduction. Man, I would love to talk to you about that. That sounds really cool. I am not a synthetic chemist. And you all just like you synthetic chemists. It's like you all know voodoo. I just love the stuff that you all do and the new things you come up with and the way you characterize them. It's really cool. So copper, trinuclear copper. So you had 3 copper centers. I can't remember what a pyrazolate is. Forgive me. And apparently you made it by shining light on this system. And that ended up reducing the copper centers somehow. That's what I'm guessing went on. So what's my opinion on CERN having the capability of changing the structure of atoms to convert? And I think that's awesome, RJ. I think that's stinking awesome. I do, Alexandra. I have a dog named Ruby. So Ariane has a husband that's a synthetic chemist. Send them my respect. Synthetic chemistry and X-ray. Cool, Abigail. Oh, I'd love to be able to get together with you and talk. So Abigail, did you like see different colors in the copper centers? I'm guessing orange, copper 1, blue, copper 2, or because you got 3 copper centers, everything is out the window and you see a bunch of different stuff? I'm curious. Hey, thanks, there, Kanika. So you saw blue to red. So I'm guessing that's a 2-to-1 transition. Again, I'm guessing because you've got 3 copper centers. That. I don't know what's going on. Cool, Abigail. So all 3 of the copper centers went from 2 to 1, and that's what caused the shift. Yeah, I do. Ash, I do live on Friday, Saturday, or Sunday. That's cool, Abigail. Okay, so just one of the three did the trans. Really? So wait a minute. You're saying you had two copper two centers. Well, actually, three copper two centers, and that was blue. And then one of them went to copper one. So you had two copper twos and a copper one, and that went red. That's interesting. That's really cool. That's really cool. That kind of blows my mind. So Sib did some summer pharmaceutical stuff, and it was about a nanomedicine. So a sugar carrier. Lumity, my favorite experiment is whichever one I'm doing at the time. It's true. It's totally true. I can't wait to share with you guys this one experiment that I did. I'm keeping it under wraps. It is so stinking cool. So be looking for it coming out. I don't think it's coming out next weekend, but the weekend after that. I've got this really cool experiment that I've got coming out. I don't think anyone's ever done it before, and it's really simple. And the chemistry involved is just going to blow your mind. So if you like chemistry and you want to see a new, simple chemistry demonstration that is really rich in chemistry, consider, subscribing and following, because you're going to see a really cool YouTube short drop in a couple weeks. Oh, thanks there, Ash. Vipin, you can figure that out. It's not too hard to figure that out. You do a little Google search and you'll figure it out. Hello there, Danny. All right, folks. Man, I had a good time. This was like this live was awesome. You all asked some really, really cool questions, and you also taught me a lot too. It was just a lot of fun. Totally a lot of fun today. So thanks. So one more thing. Let's see your thought on integrating AI, cyber security with chemistry and nanoscience. Can we apply AI and cyber security in chemistry? So Kanika, I use AI. And my thoughts on AI are the way I use it is, let's say I'm making a video. So what I do is I envision the experiment I want to do. I write, I do the filming for the experiment. I film it, and then I write the narration for the experiment, what I'm going to say. And then I feed it to ChatGPT, and then Chat and I have a conversation about it. I tell him, you're not allowed to tell me what to do. I just want to have a conversation with you about what's working and what's not, or what do you think I might be able to improve. So I just think that's a decent way to use it, right? I mean, you get to talk to this thing that has access to all knowledge. And why wouldn't I have a conversation with that thing when I'm trying to create something? I mean, it just makes sense. However, I want to do the creating. You know what I'm saying? I want to bring the human element to the creation process. So that's just what I do. Neat, Shannon. AI is only as good as its programmer. Tell me about it. All right, folks. Great hanging out with you all. We're going to see you next time. Thanks for looking at some of the beauty of science with me today, and we're going to see you next time. So long, folks.